What if you could build something so precise, so massive, so perfectly engineered that 5,000 years later, it would still make modern construction workers stop and stare? Without a single crane, without a laser level, without reinforced concrete, without GPS coordinates, without power tools of any kind? What if the people who built it had none of the things engineers today consider absolutely non-negotiable? No steel cables, no computer-aided design software, no hydraulic lifts, no synthetic adhesives, no satellite imaging. And yet they placed stones weighing as much as a loaded semi-truck with tolerances so tight you can't slip a sheet of paper between them? That's not mythology. That's not an exaggeration. That's a documented physical reality sitting in the desert outside of Cairo, and it has been sitting there, mostly intact, for longer than Rome ever existed. Here's the part that makes engineers genuinely uncomfortable when they sit with it long enough. We keep assuming the ancient Egyptians solved the problem the way we would solve it. We imagine armies of desperate workers dragging blocks through the sand under a merciless sun. Brute force overcoming all obstacles, sheer human will replacing intelligence and systems. It feels logical. It matches what we know about ancient labor. It fits the cinematic image we've been handed for decades. And yet every time modern engineers have tried to replicate even a fraction of what was achieved at Giza using only brute force and primitive tools, they fall short. They run out of time. They run out of people. The math doesn't work. The geometry doesn't hold. The structure doesn't stand. So what's actually going on? The real answer isn't that the Egyptians had more workers, or more desperation, or some mystical knowledge that has since vanished. The real answer is quieter than that, and far more unsettling. They had systems, not objects, not single solutions. Systems, interlocking, redundant, adapted to the desert environment itself, that reduced waste, reduced error, reduced friction, and reduced failure at every single stage. The genius wasn't in adding more force. It was in losing less energy to begin with. And some of those systems were so counterintuitive, so unlike anything we associate with ancient building, that when modern engineers finally reconstructed them through excavation evidence and material analysis, the response in certain academic circles was a kind of stunned silence, followed by the very uncomfortable realization: these people knew exactly what they were doing. Start with the ground itself, because that's where every building project begins, and where most people assume the Egyptians got lucky rather than skillful. The Giza Plateau is not flat. It's a gently sloping, an uneven stretch of desert limestone with natural variations in height that would make any modern site foreman reach for a surveying instrument immediately. And yet the base of the Great Pyramid is level to within a margin that some researchers estimate at just a few centimeters across a footprint of over 13 acres. 13 acres. That's not luck. That's not approximate. That's a level of precision that requires either extraordinary technology or extraordinary technique. And when modern analysts began examining what technique might have been used, they landed on something deceptively simple: water. Some researchers argue that the Egyptians may have used a network of shallow channels cut into the bedrock and filled with water to establish a perfectly level reference plane across the entire construction site. Water doesn't lie. It finds its own level regardless of the irregularities of the ground beneath it. You cut channels, fill them, mark the water line, drain the channels, and you have a flat reference grid encoded into the stone itself. No electronics, no satellites, no laser leveling equipment. just the physics of a liquid surface at rest in a desert that stretches from horizon to horizon. But here's the part nobody expects. That same water in a desert wasn't just a surveying tool. Water, or more precisely the behavior of wet sand, appears in other evidence connected to the construction process in a way that changes the entire picture of how blocks were moved. A wall painting found in the tomb of a regional governor shows a procession of workers dragging a large statue on a sledge across the ground. Nothing unusual about that. Sledges were a known and documented method for moving heavy objects. But in the painting, a figure at the front of the sledge is clearly pouring something from a vessel onto the sand directly in the path of the sledge. For decades, this was interpreted as a ceremonial gesture, a ritual, a religious offering of liquid before a great task. It felt logical, and yet it was wrong. Modern tribology, the science of friction, tells a different story. Dry sand under a loaded sledge creates enormous friction. The particles shift and pile in front of the runners, requiring constantly increasing force to keep the sledge moving. But wet sand behaves differently. Wet sand compacts. It forms a stable, low-friction surface that allows a sledge to glide with a fraction of the resistance of dry desert ground. The figure in the painting wasn't performing a ritual. He was a lubrication technician, doing a precise and practical job, managing the interface between the sledge and the sand with the same functional intention a modern engineer would use synthetic lubricant on a machine component. Some researchers who modeled this experimentally found that optimal sand moisture could reduce the pulling force required by approximately half. In a project that involved moving millions of tons of stone, cutting the required force in half isn't a convenience. It's the difference between possible and impossible. And heat isn't just temperature, it's time. And in Egypt, time lost to the wrong conditions was the one resource that could never be recovered. The construction season wasn't random. Some evidence suggests that major stone-moving operations were concentrated during the Nile's inundation season, when the floodwaters covered the fields and the agricultural workforce was temporarily freed from farming. This wasn't merely a labor scheduling convenience. The flooded landscape created navigable waterways that extended deep into regions normally accessible only by long desert overland routes. Stone from quarries at Tura and Aswan could be floated on barges across floodwater channels far closer to the construction site than would otherwise be possible. The river became the highway. The flood became the logistics infrastructure. The timing of the construction was engineered around the behavior of the Nile. The geography of Egypt itself was built into the construction plan. The workers, the water, the stone, the timing, all of it was synchronized to the rhythm of the desert environment rather than fighting against it. Nothing worked in isolation. The ramp question is the one that has generated the most debate, the most controversy, and in some corners, the most resistance to accepting that the answer might be far more elegant than the textbook image suggests. The standard explanation for how the Egyptians raised multi-ton blocks to heights of over 140 meters is a single massive external ramp of earth and rubble, growing longer and shallower as the pyramid rose. It feels like the obvious answer. And yet engineers who have done the math keep running into the same problem. Such a ramp would require as much material as the pyramid itself, possibly more. It would need to be built, then demolished, generating a debris problem at least as enormous as the construction problem. and there is no archaeological evidence for the debris field such a ramp would leave behind. Some researchers now argue for a different configuration entirely, an internal spiral ramp ascending through the body of the pyramid itself, cut into the outer casing blocks as the structure rose, then sealed and finished as the pyramid was completed from the top down. Some analysis of the pyramid's internal geometry, combined with evidence found during recent non-invasive scanning projects, offers at least partial support for this interpretation. Not proven, not certain, but far more consistent with the physical evidence on the ground. The ramp wasn't the brute solution we imagined. It was either hidden, or it was internal, or it was a combination of both. And in any of those cases, it was a system, not a single tool. And that's when the real problem starts to come into focus. Because if the ramp is more sophisticated than we assumed, and if the logistics were more synchronized than we imagined, then everything else we think we know about pyramid construction starts to require a second look. For centuries, the dominant image of the workforce was slave labor. Thousands of expendable people driven by fear and force, their suffering converted into stone. And yet, archaeological evidence uncovered at Giza tells a markedly different story. The workers' village, a real, physical settlement excavated near the pyramid plateau, shows evidence of a housed, fed, and medically attended workforce. Bakeries and breweries capable of feeding thousands of people daily. Cattle bones indicating a high-protein diet. Evidence of healed fractures suggesting injured workers were treated and returned to work rather than simply replaced. The graffiti left by work gangs with names like Friends of Khufu and Drunkards of Menkaure. A level of identity and apparent group pride inconsistent with a slave workforce, and very consistent with something closer to a rotating, specialized labor force organized into skilled teams. The pyramid wasn't built on suffering alone. It was built on organization, on logistics, on a human management system that kept tens of thousands of workers fed, housed, motivated, and medically functional in a desert environment over a period of decades. That is an administrative achievement that would challenge modern project managers, and it was executed without computers, without radio communication, and without refrigeration. The fifth secret lives in the stone itself. Some researchers have argued, with supporting chemical analysis, that a portion of the blocks, particularly in the upper reaches of the pyramid, where transporting quarried stone becomes exponentially more difficult, may be a form of cast stone, a geopolymer concrete made from a mixture of limestone rubble, water, and natural mineral binders available in Egypt's desert environment, poured into molds on site rather than cut from a quarry and hauled into place. This claim has been contested. The debate is genuinely unresolved. But what's striking is not the specific conclusion. It's what the debate itself reveals about the sophistication of the problem. If you're standing at a height of 100 meters trying to place a block of stone, and your entire logistics infrastructure is built around moving stone from the ground up, then at some point, the system has to change. The Egyptians may have understood that a different problem required a different material, not one answer. A system that adapted in a nothing worked in isolation. The four sides of the Great Pyramid are aligned to the cardinal directions: north, south, east, west, with a margin of error of less than 1/10 of a degree. This is not approximate alignment. 1/10 of a degree is a precision that modern surveyors with GPS instruments would be satisfied to achieve. The Egyptians achieved it in a desert, before the development of the magnetic compass, without any instrument we have physically recovered. One plausible interpretation involves stellar observation. The rotation of the night sky around the celestial North Pole creates a visible arc traced by circumpolar stars, stars that never set below the horizon. By bisecting the rising and setting points of a selected circumpolar star from a fixed observation point, it may be possible to identify true north with remarkable accuracy. Some researchers have modeled this technique and found results consistent with the alignment precision actually observed in the pyramid. No magnets, no satellites, just the geometry of the sky above the desert, read by people who had been watching it for generations. The desert at night is cold and clear and full of stars, and the Egyptians were not passive observers of it. They were engineers who used it. The seventh secret is the one that ties everything else together, and it's the one that modern engineers find hardest to fully absorb, because it requires accepting a kind of intelligence that doesn't look like intelligence from the outside. The Great Pyramid has no single masterstroke that explains it. There is no one invention, no one technique, no one secret that unlocks the mystery. What there is, instead, is a cascade of small optimizations, each one modest on its own, each one targeting a specific friction point in the process, that compound over time into something that looks, from the outside, like magic. Wet sand under the sledge, water channels defining the level baseline, Nile flood timing coordinating the logistics, a workforce organized into skilled rotating teams with medical support and consistent nutrition, stone possibly cast in place at upper levels to reduce the transport load, stellar geometry fixing the cardinal alignment before the first stone was placed, internal ramp structures spiraling upward inside the growing body of the structure itself. Take any one of these elements alone, and you have an interesting technique. Put them all together, synchronized, interdependent, each one reinforcing the others, and you have an engineering system that solved the problem of building the largest stone structure in human history in a desert with limited water, limited metal, and a workforce that needed to eat, sleep, stay healthy, and show up tomorrow. The genius was systemic. It was distributed. It was not concentrated in a single moment of inspiration, but embedded in 1,000 daily decisions made by people who understood their environment deeply enough to use it rather than fight it. The builders of the pyramids did not overcome their environment. They read it, they used it, and they built it into their system so thoroughly that the desert itself became part of the construction infrastructure. Modern passive architecture borrows from these same principles without always knowing it. Thermal mass, natural ventilation, site orientation relative to the sun, material choice based on the local environment. The desert taught these things long before they became keywords in green building certification programs. What you assumed was primitive was actually precise. What looked like brute force was actually management. What seemed like mystery was actually a system so well adapted to its context that its traces dissolved back into the desert over millennia, leaving only the result standing against the sky. 7 secrets, 7 systems, one structure that has outlasted every civilization that has tried to surpass it. And the real question isn't how they built it. The real question is what else they understood that we still haven't figured out how to read. If this changed the way you think about what ancient people were actually capable of, drop a comment below and tell me which of the 7 surprised you most. Subscribe and turn on notifications, because the next video goes even deeper into how the Egyptians engineered water in the desert in ways that modern cities are only now beginning to study seriously.